Hey everyone, it's great to be back with you at P99Conf, my favorite online conference. And today I'm going to be talking about sharpening the axe, the primacy of toolmaking. And sharpening the axe, you may recognize as this Abraham Lincoln quote, give me 6 hours to chop down a tree, and I will spend the first 4 sharpening the axe. Seems like great wisdom about the importance of using the right tools and spending real time and investment on your tools. But I was wondering, as you might have been, first of all, I'm not really an expert on chopping down trees. I have chopped down a tree before. I have used an axe before. I'm not an expert. 4 hours to sharpen an axe? I mean, doesn't it feel like there's some diminishing returns in there somewhere? That seems a little, that seems a lot. I mean, I don't want to second guess our favorite country lawyer president, Abraham Lincoln. But the time balance seems a little weird. And did Abraham Lincoln often talk about these kinds of things? But as I looked at this quote, I wanted to understand a bit, like, what did Abraham Lincoln actually say? Turns out a little bit more Googling reveals that, well, actually, maybe it's not 6 hours. Maybe it's 8 hours to chop down a tree. And we're going to spend the first 6 sharpening the axe. It's like, okay, how much additional sharpening do you get in hours 5 and 6? Out of curiosity, and now we've gone from 2/3 of the time sharpening the axe to 3/4 of the time. I mean, I get the aphorism, but like drilling down in the specifics a little bit, like what's going on here? Of course, a little bit more searching reveals like, no. It turns out it's 4 hours to chop down a tree, and I'm going to spend the first 2 sharpening the axe. Still feels like a long time to sharpen an axe. Yet more searching reveals that no. It is give me an hour to chop down a tree, and I will spend the first 45 minutes sharpening the axe. That feels like we're bringing the sharpening time down into something that's a little bit more reasonable here. And just to be clear, these are all example quotes that I found of people attributing this verbatim text to Abraham Lincoln. Well, as you might be inferring, Abraham Lincoln didn't actually say anything like this. This kind of reminds me of, it took me years of getting into adulthood to realize that Benjamin Franklin really didn't say many of the things that my father claimed he had said. Ditto Mark Twain or Eleanor Roosevelt. These folks just get this kind of folksy aphorisms. Wisdom gets attributed to people that we hold in high regard, including obviously Abraham Lincoln here. And I found there's a great quote investigator piece that goes into this quote from Lincoln and does some deep research about where does this whole axe business come from anyway. And perhaps not surprisingly, it's biblical. So this comes to Ecclesiastes 10:10. If the iron be blunt, he do not whet the edge, then must be put to more strength. But wisdom is profitable to direct. I feel like I need to say that with like a Mennonite beard there. But this is a sermon that's kind of interpreting this in terms of sharpening the axe. This is from 1856 as this article unearthed. And this is, of course, before Lincoln is president, and it's not exactly the aphorism that we saw anyway. Actually, on this, I was a little bit curious, and I'm just apologies for rabbit holes yielding yet more rabbit holes. But wisdom is profitable to direct. It's such a strange way of phrasing things. I made the huge mistake of actually looking this up in different biblical translations. As it turns out, this gets translated wildly differently, including in one case that skill is of no advantage to a man. So don't look too much at this. I'm really sorry if I've already sent you down this rabbit hole. Let's back up from biblical translation for a moment and get to actually, here is what the quote that we've come to know. A woodsman was once asked, what would you do if you had just 5 minutes to chop down a tree? And he answered, I would spend the first 2.5 minutes sharpening my axe. This makes a lot more sense. This is from 1956. And this is when this aphorism kind of comes in to the common zeitgeist, this idea and that we later attribute to Lincoln in an advertisement, as it turns out. But this idea that toolmaking is important. And of course, we know that toolmaking is important. Toolmaking is the actual essence of our humanity, is that we make tools. We change our environment to make things that will make other things. It is the core of who we are. And we know that better tools yield better artifacts. We know this for effectively all domains, that we spend that the time spent making tools yields better things. Part of the challenge with toolmaking, just like that sharpened axe, however long you spent sharpening it, is the tools themselves are entirely invisible to the end user of the product. They're often not even present in the product. In fact, most often they're not present in the product. In fact, the product may have no difference than the product you would have gotten otherwise. Maybe it was just done faster or cheaper or better because of a tool that you, the user, could not see. And this leads us to not place much importance on toolmaking or not place sufficient importance on toolmaking. We don't explicitly encourage it. It can feel like a distraction. This is too bad because honestly, some of the most consequential developments in software history, certainly, were actually groups that were seeking to build tools to build the end thing. And it's those tools that became great contributions. So I want to go through just a few of these. I think many of these we commonly know, but it's worth going through a couple of these to see this very profound trend, some of these commonalities. So the first one, of course, is the classic. I feel like, my own history I feel like I end up going back to Unix history over and over and over again and seeing different aspects of Unix history, the development of Unix, kind of the birth of modernity with respect to a software system in the late 60s, early 70s at AT&T Bell Labs. It was a hugely seminal moment in many different regards. Not least this kind of tool-making perspective, because when they were developing Unix, and truthfully, they wanted to develop an operating system, they were figuring out how to get it funded. But one of the things that they saw is that AT&T really needed a better way to typeset their patent applications. And they felt that they could develop a system that would allow them to develop those patent applications or to typeset those patent applications better. What is interesting, I think, is that, so yes, they were trying to justify the system that they were trying to build anyway, but in building that system, they began to realize that actually the system itself has even greater utility than we realize. This is an excerpt from Dennis Ritchie's The Evolution of the Unix Time-Sharing System. Just as a brief and ironic aside, you may notice that the capitalization here is different. Unix actually should not be capitalized. The reason that you will see Unix capitalized, as in this excerpt from the Bell Systems Technical Journal in 1984, is they made the mistake of showing off what their typesetting could do by using small caps when they actually spelled Unix. So Unix was in small caps, something that most pieces of software can't do. And I'm not even sure pieces of software today can do it. I don't think Google Slides can do small caps, or if it can, I couldn't find a way to do it. So they ended up with these two conflicting capitalizations of Unix. So for your inner pedant, it should really be Unix lowercase nix, not in all caps as you see here. I think this really got under Dennis Ritchie's fingernails for as long as he lived. But the Unix itself had utility beyond just the development of this document system. That in developing this, they saw that there was a general purpose utility, that the tool itself was actually becoming, even in this case, perhaps more valuable than the artifacts that it was creating. And they actually didn't want to scrap Unix when they were done with this experiment. We want to continue developing this system. So it was an early dividend that we got from investing in tooling in Bell Labs in the late 60s and early 70s. Another great example, and perhaps a crisper example, because in this case, Don Knuth, the great computer scientist, was trying to solve a problem. And the problem that he was trying to solve was updating the second edition of the Art of Computer Programming. And what had happened between the first edition and the second edition is that typesetting had changed. And instead of using historic typesetting mechanisms, hot type mechanisms, they were now using digital typesetting. And he really didn't like the layout. And like the great computer scientist that he is like, wait a minute, this is a digital system. I do digital systems. I should actually build the tool that I, Don Knuth, need to typeset my own book. And he wrote this preliminary description of tech. He wrote it in 1977. This is, and I'm going to warn you before you click on this link, this will take you into an absolute rabbit hole. This is the Sail Dart from the Stanford AI Lab. This is their entire file server that is online. And it's like Don Knuth's home directory from the 70s and 80s is just online. And it's remarkable. Things that were certainly intended, I think, to be private. One of the things I learned is that my one of my neighbors got an A+ on a midterm from Don Knuth just by browsing around this. But the mesmerizing content here, including this memo in which he writes down what he wants to go do. And what he wants to go do is wants to create the tool that he needs for the art of computer programming. And the art of computer programming is the artifact, and indeed he's focused on that. I'm preparing the system primarily for use in publishing my series, The Art of Computer Programming, but hey, maybe this will be useful for someone else. It will not be difficult to extend it for other purposes if anybody wants to do so. And tech, of course, became hugely important. Tech and then law tech became hugely important and used the world over to write technical documents. So a very, very important development of a tool. And we should feel lucky that a computer scientist had this problem early on and had this zeitgeist, this ethos around building a tool. Another one that you may not have heard of, I think you probably have heard of Unix, and I think you probably have heard of tech, but you may not have heard of NSELite. NSELite is a very important body of software that came out of something called NSE. NSE was the network software environment at Sun Microsystems in the late 80s, early 90s. And it was a horrific way of developing software. And there was a rebellion inside of Sun, very much led by Larry McVoy, to develop a new way, or actually, honestly, develop any way of developing software. What Larry had figured out is that under the hood, NSE was using SCCS, and he could develop another body of software that would talk straight to those SCCS repos. He developed NSELite, and NSELite is important because it's the first embodiment of what we would call the bring over, modify, merge model of software development, where instead of checking out one file and you can't operate on this file because I am operating on it, I'm going to take the entire repository. I'm going to check out the entire repository. I'm going to modify all of these files in a self-consistent way. And then I'm going to take all of that together and I'm going to push it back into the gate once I have no conflicts. And this was extraordinarily important. If it feels like this is obvious, it certainly wasn't. This was a body of software that was way ahead of its time. And it was done because McVoy needed this tool to do his day job. This is a very important point. McVoy was in, at the time, was Sonos and Solaris kernel development. He is trying to develop the operating system. And in order to develop the operating system at all, he needed to subvert the system called NSE with NSELite. NSELite, and you may recognize the name Larry McVoy. Larry left Sun, later went to SGI, left SGI, and then started a company called BitKeeper. And BitKeeper was the first commercial embodiment of the bring over, modify, merge model. NSELite later became Teamware inside of Sun. Teamware, very important body of software. It's what I grew up on when I was in Solaris kernel development way back in the day. And when I was using Teamware, I felt like I was living in the future, because in the late 90s, we were using the bring over, modify, merge model, but the rest of the world broadly was not, using subversion and perforce and other things. But NSELite and then Teamware was very important. Larry went and did BitKeeper. BitKeeper was used and ultimately was what converted Linus Torvalds to source code management. BitKeeper, they ultimately had a license dispute, and Torvalds and the Linux kernel team developed Git. So NSELite is in a very direct fashion the grandparent of Git, very much inspired the model, very important. And the genesis of that was someone trying to get their job done. It was Larry at Sun, and then it was later Linus with respect to Linux kernel development. So Git very much owes its existence to this model of people developing the tools that they need. Then this is one. It's actually kind of hard for me to talk about history and then kind of inject my own thing in here, but this is a very personal story for me. I, along with Adam Leventhal and Mike Shapiro, developed DTrace at Sun Microsystems. DTrace very much was the thing that we needed. I joined Sun in 1996 to do Solaris kernel development, specifically Solaris performance. And to understand the performance of the system, I needed to know what software was actually executing. And in order to know that, I found that I really needed to be able to instrument the running system. That idea of how do we instrument running program text became DTrace, very much informed by 5+ years of actually trying to understand these systems. And DTrace was surprising to me in that its utility went far beyond the kernel. When we did user level tracing, Adam Leventhal did user level tracing. It almost felt like, I mean, we knew it was important, but I think we had no idea how important it was going to be able to stitch together what was happening in the user level, with what was happening in the kernel, and find these huge performance problems up stack. Of course, in a stack of abstraction, the biggest performance problems are not at the lowest layers of the stack. They're at the highest layers of the stack, because less lines of code does more work. It means that less errant lines of code can do more unintended work. So this was not something I would have expected. And it was a huge dividend from DTrace. I dare say that DTrace inspired other systems that we have today around instrumenting the system, which is great. But the idea that we need to instrument the system to be able to understand it, it was revolutionary in its day. And no one was really focusing on that, even though I desperately needed that tool. And again, I needed that tool not because I thought someone else might want DTrace. I built DTrace for me. We built DTrace for us. We did it so we could do our job, and we never lost track of our own job in doing it. One of the things that's been gratifying about my own career is to be able to build things like DTrace and continue to use them as my career progresses. And actually, I was almost embarrassed to ask the question, but a couple years ago, I did ask Jeff Bonwick and Matt Ahrens, to what degree did DTrace assist the development of ZFS? And, I kind of got shot a look like, I was asking a silly question. And I'm like, no, is that like, I don't know. Did it help? And the answer was, of course it helped. And DTrace was critical for the development of ZFS. DTrace played all of these dividends that I didn't really even appreciate at the time, because it allowed people to develop software better. And that kind of ongoing dividend is something that's very hard to anticipate as a toolmaker. When we first set out to build DTrace, we had no idea what the consequences were going to be, how broad the consequences were going to be, how much software it was going to help accelerate, where it would find these problems. It would have been very hard. I mean, I would say we didn't suffer from lack of ambition for DTrace. When we got management authorization to really go take a swing at this in 2001, we definitely had ambition. But even with our ambition and our scope, we didn't foresee all of the advantages something like DTrace would have. So it was a lesson for me, certainly, in the value of toolmaking and the unanticipated dividends that toolmaking can bring. Another example from Sun that was roughly contemporaneous with me, albeit in another universe, Kazuki Kawaguchi from Sun developed something that was originally called Hudson. It was after Oracle bought Sun, they insisted on not allowing the name to be used. So Hudson changed its name to what you probably know it today as Jenkins. But Hudson came out of this need where you had Kazuki, who was working on Jaxby, which is an XML goober, again, far away from where I was in kernel development. But what he found was that he needed ways to actually continuously build the system. And Hudson was the thing that he needed to do his job. And as a result, Hudson had great utility, and Hudson found purchase far beyond the walls of Sun. Another one that's close to me now, because it's the tool that I use very frequently now, is Rust. And Rust was born at Mozilla, and it was born because Graydon Hoare was seeing all of the challenges of C++, and trying to figure out how can we take these C++ systems and evolve them. And Rust was his answer to that. And there's a lot of, and this presentation from 2010 is mesmerizing, because of course a lot has changed in Rust in the last 12 years, but there are some things that the bones are very much there. And in particular, the bones that I love in this presentation in 2010 is the emphasis on practicality in Rust. He's not trying to innovate for its own sake, not trying to be Haskell, trying to see the advantages of something like C++ and deliver it in a vehicle that can be made memory safe, where you can make it easier for someone to write a safe program. That very much lives on with us today in Rust, and we owe it to this mentality that Graydon had, and Mozilla, to its credit, had, of allowing folks to find the right tool for the job and to invent that tool if and as needed. So these are high-profile examples, but there are many, many, many more that we collectively have not heard of. Much smaller tools closer to home. You probably have a bunch in your own career, in your own environments. You've got small tools that people invented along the way. And there are some commonalities, though, that made these things successful. One of them that I very strongly believe in is that these folks were building the tools that they themselves needed. They were not building the tools for someone else. They were not having a product manager give them, the Jira tickets of the things that the user needed in the user stories and all this business. Fine for building certain kinds of software. But for this kind of software, these were tool makers building the things that they themselves needed. And these things that they were building did not have necessarily immediate tangible value in and of themselves. They were resulting in building better artifacts. And it was because these tool makers were building themselves the things that they themselves needed, that they weren't actually independently monetizable. They weren't being built as their own vehicle or their own vessel. They were being built to help them do their day job. And the result is that they ended up having much greater utility. These things were really useful. They were born useful. They have remained useful. So given all of this, why is there this kind of prevailing zeitgeist that toolmaking is discouraged? Because a lot of people feel that toolmaking is discouraged. Why would someone discourage toolmaking? And the reason that toolmaking is implicitly or even explicitly discouraged is pretty simple. The payoff is at a distance, but the cost is immediate. We know that the today that you spend working on this tool, we know that that's a day you're not going to spend on the software today. That this day may save us 10 a year from now, that's unseen. That's unknowable when you spend this day. All we know is the immediate cost that you had today working on this tool instead of working on the artifact that you're responsible for delivering. So that's why toolmaking has felt, frankly, like stealing time. Toolmaking has lurked in the shadows. It's been done on the sly, serendipitously. Sometimes, without management's knowledge or authorization, these things have been done. And that's not a good place for things to live. And we shouldn't have to do something that is so obviously valuable on the sly. And yes, it is in principle to spend too much time on toolmaking. It's possible to overly fixate on toolmaking, but I would say that that's the exception. That's not the rule. I think that it is I think in my experience, toolmaking is actually unlikely to be the wrong use of time. It's just difficult to quantify because it has this payoff in the future. And indeed, what things have a payoff in the future that cost us in the present? Investments. That's what an investment is. An investment costs you in the present, but has payoffs in the future. Toolmaking is very much an investment. And just as we talk about kind of technical debt in financial terms, I think we may want to think about toolmaking in financial terms. Toolmaking as an investment. And just as with an actual investment, if your time horizons are too aggressive with toolmaking, if you insist on toolmaking paying dividends in days or weeks or even small number of months, if you say, oh, no, we're free to work on toolmaking, I just need to know this is going to pay off in 2 months. It's like, well, that's a pretty aggressive timeline. And that's going to lead you to some very conservative decisions. That's going to lead you to the tool making equivalent of a treasury bill, treasury bond. It's just like that's not going to allow you to do the things that are going to have those outsized returns. Certainly, you're not going to do DTrace, you're not going to do Unix, you're not going to do Rust on when you've got that kind of tight time horizon. You need to expand your time horizon and be willing to take more risk with the understanding that investment in toolmaking often compounds. Compounding interest is that, this is the probably also apocryphal quote from Einstein about the miracle of compounding interest. Compounding investment is extraordinary because dividends that we get early in the investment's life get reinvested. We see this in toolmaking all the time, where toolmaking has early advantages that then get plowed into the toolmaking itself, or they get plowed into the artifact. The artifact accelerates earlier because the tool was present. So if you find that toolmaking is always paying off, it may indicate that there's an insignificant amount of risk, that you need actually more risk. You got to have some tools that don't pay off. That said, it's a real struggle for me to think. Honestly, it's a struggle for me to think in my career of the tools that were turkeys or duds that didn't pay off. I mean, you can find them a little bit, but the ones that paid off so vastly outnumber the ones that didn't pay off. And they paid off in ways that were delightful and unexpected. So we need to encourage toolmaking. The downside is bounded to the time spent. The upside is often completely unbounded. And people are kind of concerned that, like, boy, I'm going to, capsize my company if I focus on toolmaking. That's not what's going to capsize your company or your team or what have you. What's going to capsize your company is building something that no one wants. That's what's actually going to capsize the company. And when you're building a tool, when you're building a tool that you yourself need, you are tautologically building something that someone wants. Now, that someone is just you, and maybe you're not a big enough demographic to actually build a business on, but that's in contrast to the other thing you're building, which maybe no one wants, by the way. And it shouldn't be that much of a surprise that toolmaking has actually saved more than one company. In fact, it saved one entrepreneur, Stuart Butterfield, twice. Flickr and Slack both started off building games, actually. And then when those games proved to be not very interesting to people, they pivoted into the tool that was underlying the game that was valuable. Photo sharing for Flickr, chat for Slack, Docker, similarly with .cloud. .cloud as a service wasn't really going anywhere, but the tooling, boy, that tooling was really interesting. The tooling was more interesting than the thing. And that's in part because they were building the tooling for themselves. They knew they had a demographic of at least one. So when engineers want to make tooling, they should be encouraged to do so. But how do you do that when you got tight deadlines, you got aggressive schedules? Like, how do you justify the time for tool making? It is absolutely hardest when the deadlines are tight, when the opportunity cost seems high. That is when it is hard to encourage toolmaking or believe in toolmaking. But you've got to remember, we engineers are cognizant of those deadlines. We are cognizant of those deliverables. So if you as an engineer or an engineer you work with has these deliverables and is beginning to think, God, I know we got this tight deliverable, but if I could only invest a little bit of time in this tooling, I think it would save time in the long run. Just by the fact that you're having that conversation with yourself, it is almost certainly the case that it is the right thing to do to invest in that tooling, especially when that tooling is going to lead to more knowledge and understanding of the artifact. The best time to develop a debugger is when debugging. And the best time, at P99, we're talking about systems. We're talking about that 99th percentile a lot. It is our tooling that allows us to debug those systems, allows us to find those performance issues, those latency outliers. It is the tooling that allows us to find that stuff. And the best time to do it is when we're actually debugging it. But in order to be able to have an organization that promotes tool making, we need that most fundamental currency of the realm for creative endeavor, and that is trust. We have to trust one another. We have to trust ourselves, the people we work with. We have to trust them that they are actually going to make the right decision. Trust is how we build organizations. It is the most important element in any engineering organization. So if you want to value toolmaking as an engineering, start by building trust. Tell engineers, we trust you to make the right decision. We trust that you're building the right thing at the right time. We trust that you've made the right decision to build this tool today and not work on the artifact today, because we know that the dividends that this will pay off in the future will be much greater than the time that you've invested. With that, thank you very much.